all the way to the etcd store. So etcd contains the configuration for our entire state. So in here, I'm in the official website for etcd, and you can see that it's a distributed reliable key value store for most critical data and distributed system. You see that the features, it's simple interface, it has a key value storage. You can see that it stores the data really organized in directories as in the standard file system. And here it watches for changes on specific directories, and it also reacts to changes. And you'll see why this is important in a second. So if I scroll down, you can see that the adopters, so here Kubernetes is the backend for service discovery and stores cluster state and configuration. So this is really important. This is really important. And also you can see that etcd is written in Go, which has excellent cross-platform support, small binaries, and great community behind it. And communication between etcd machines is handled by the Raft consensus algorithm. So you're going to learn about this later in this course, but I just wanted to show you that etcd is really, really nice, and it's been adopted by quite a lot of organizations and projects, and you should be aware and familiar with it. Now, let me go back to the slides and learn about the scheduler. So the scheduler watches for new workloads, pods, and assigns them to a node based on several scheduling factors. Is the node healthy? Does it have enough resources? Is the port available? Affinity and anti-affinity rules, and other important factors. So you can see that it's a really important component. Next, we have the controller manager. So this is a daemon that manages the control loop. So basically, it's a controller of controllers. In Kubernetes, we have a bunch of controllers, and let me just show you the node controller. And what this controller does is whenever the current state doesn't match the desired state, then it reacts to those changes. In our example here, we are setting the desired state equals to 1 node. And this is not the actual way to do it, but this is just an example. And if we have 1 node, then if this node dies, right? So if this node has a problem, maybe it has a disk failure, or it ran out of memory, or any other factor. So if this node dies, then the node controller is responsible for bringing another node. So you see here, so this is the purpose of the node controller. We have other controllers such as the replica set, which is responsible for ensuring that we have the correct number of pods running. We have the endpoint controller, which assigns pods to services, namespace, service accounts, and others. And to put it this way, what the controller manager does, it simply watches the API server for changes. And the goal is to watch for any changes that does not match our desired state. So we have a desired state and we have the current state. If the desire doesn't match the current state, then the appropriate controller kicks in to try and match the desired state. So a controller is simply a watch loop. We also have the Cloud Controller Manager, and the Cloud Controller Manager is responsible to interact with the underlying cloud provider, such as AWS, Azure, or Google Cloud. So in this example here, we have a bit of configuration, and you're going to learn about all of this and what it means. But basically, this configuration right here, or this manifest, I've called ingress.yaml, contains an ingress, and this gives us a load balancer. Now, first, this request goes through the API, and then that gets stored, and then the Cloud Controller Manager kicks in. Now, depending whether you are running Kubernetes on AWS, for example, then it creates the load balancer, which is an ALB, application load balancer. If you're running within Azure, then it creates the equivalent, but using the Azure Cloud API. The same for Google Cloud. So you see that the Cloud Controller Manager is responsible for interacting with the underlying cloud API provider. So you've seen how it does it for load balancers, but it's the same with storage or instances. So these are VMs. And to be honest, these are all of the components for the master node that makes up the control plane. So the master, in a nutshell, runs or clusters control plane services. And as I said before, it's the brains where control and decisions are made. And there we go. You now know about the control plane and master node. Next, let's go ahead and learn about the worker nodes. So you've learned about the control plane and master node. Now let's focus on the worker nodes. So as I said before, the worker nodes, this is where the heavy lifting work happens. So the worker node is a VM or a physical machine often running Linux. It provides the running environment for your applications. So this is our worker node, and inside we have the applications. So right here, so we have a pod, and you're going to learn about pods later, but this is for now, you can think of a pod as a container in the Docker world. And one thing to note here is that when deploying your applications, you should really be deploying microservices. So here we have 3 microservices, so microservices A, B, and C. If you want to deploy monolithic applications, then you should really be considering splitting into small microservices, because this is where Kubernetes does shine. And also, microservices is the standard these days, and this is where the industry is moving. So moving on to worker nodes, the worker node has 3 main components. So if we look into it, so here we have the worker node, and inside of each worker node, we have the kubelet, which is an agent, and you're going to learn in a second what it is. You also have the container runtime. I'm going to explain this in a second as well. And also we have the kube proxy. And remember, I said that the node itself is actually a VM or a physical machine. So in this example, let's say that this is a VM which runs Linux with 4 cores, 32 gig of RAM, and 100 gigabytes of SSD storage. So you can see that this node has 3 components: kubelet, container runtime, kube proxy, and it runs on Linux. So let's learn about the kubelet. So the kubelet is the main agent that runs on every single node. It receives pod definitions from the API server. It also interacts with the container runtime to run containers associated with that pod, and it reports node and pod state to the master node through the API. So here you can see that the API talks to the kubelet, and the kubelet also talks back via the same channel, and the kubelet also interacts with the container runtime. So what is this container runtime? Well, the container runtime is responsible for pulling images from container registries such as Docker Hub, GCR, ECR, and ACR. So these are some of the popular ones. But basically, it's responsible for pulling images, starting containers from those images, and also stopping containers. So the main thing here is that it's responsible for running containers, and it abstracts the container management for Kubernetes. And within it, we have the container runtime interface, and this is an interface for third-party container runtimes. So you might have heard that Docker was recently deprecated by Kubernetes, and this is because it's in favor of Containerd, which is becoming now the standard container runtime for Kubernetes. So let me quickly show you. So right here, I'm inside of the Containerd official page, and you can find the link for this website under the description of this video. And you can see that they say it's an industry standard container runtime with an emphasis of simplicity, robustness, and portability. And as of the 28th of February of 2019, Containerd became part of the Cloud Native Computing Foundation, following Kubernetes, Prometheus, and others. So basically, you can see that they explain the ecosystem in here, And right here, you can see that we have the kubelet, and right here we have the container runtime. And here they say that it manages the complete container lifecycle of its host system, from image transfer and storage to container execution and supervision of low-level storage to network attachments and beyond. So I'm going to leave the link for this page right here. You can see the adapters, so IBM Cloud Kubernetes Service, Google Cloud right here, Docker as well, Instana, Firecracker, and others. So go ahead and check this link to learn more about Containerd. If I go back to the slides and move on to the last component within the worker node, which is the kube proxy. So the kube proxy is an agent that runs on every node through a daemon set, and it's responsible for local cluster networking. It makes sure that each node gets its own unique IP address, and it's also responsible for routing network traffic to load balance services. So you're going to learn about all of this in a second. So for example, if two pods want to talk to each other, so kube proxy is what's doing the magic. If you as a client wants to send a request to your cluster, kube proxy is responsible for handling all of that. So there you have it. Now you know about the three main components within the worker node. And also you've learned about the control plane, which gives you the complete picture of the entire Kubernetes architecture. So knowing all of these components and how they work together will make you understand everything once we start using Kubernetes. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. Previously, you've learned about the Kubernetes architecture and you saw how all of these components do work together and what are their purposes. Now let's focus on running Kubernetes. When it comes to run Kubernetes, we can do it in a couple of ways. One, we can run it ourselves, which is really hard, or we can use a managed solution. Now, this is what most companies using Kubernetes in production do adopt, because it removes lots of overhead when it comes to maintaining the cluster. And the most popular managed Kubernetes providers are EKS, so Elastic Kubernetes Service, and this is from AWS. We also have GKE, so this is the Kubernetes, or actually Google Kubernetes Engine. And we also have Azure Kubernetes, which is from Microsoft. And obviously we have other cloud providers as well. But what does it mean to be managed? Well, if we start from our cluster, you saw that we have the control plane, right, which is made of all of these components. And what it means to be managed is that you don't have to worry about the master node as well as all of these services that run within the master node, such as the scheduler, the API server, the cluster store, control manager, cloud control manager, so on and so forth. So all of this is fully managed for you. And all you have to do is just focus on the worker nodes, and this is where your applications do run. So you see that now all of a sudden you remove a lot of complexity and you just have to focus on your application itself. So if you were to manage, for example, the master and all the services within it, the control plane, for example, managing the data store, etcd, replication, making sure that it's high available, so on and so forth, can be a lot of pain. Now, let me give an example of how EKS makes our lives much easier. So EKS, as I said, is a managed solution from AWS. And basically, they give you a cluster and then you decide how you want to run your applications. So currently there are two ways. You can run it using AWS Fargate. So this is mainly for deploying serverless containers, or you can run EKS using EC2. So this is where you deploy your worker nodes for your EKS cluster. So the difference between these two is that the EC2 is for long running applications, where the Fargate is mainly for serverless containers. So applications that don't need to be running all the time. And from this, you can see that it's much easier. and you can then pretty much just run your Kubernetes applications. And this is really cool. Now, when it comes to learn Kubernetes, you shouldn't really be using these managed services because one, it's expensive, and it's not the best way of you to learn Kubernetes. So these managed services, they're used when you want to take your application to real users or testing environments. So to run Kubernetes locally, i.e. to create a local cluster, there are three main solutions out there, or there are others, but these are the most popular ones. So we have Minikube, we have Kind, and we also have Docker. All of these three solutions allows us to basically create a local cluster that allows you to play around and learn Kubernetes. Now, just to be cautious here, these three solutions are mainly used for learning purposes. It's mainly used for local development or continuous integration. And as I said, so this is an important note. Do not use it in any environment, including production. Now, for this course, we're going to use Minikube, and this is because Minikube has a great community, lots of add-ons and features, and it has great documentation. And also, you'll see plenty of tutorials out there based off Minikube. Now, the installation process, it's really simple. All you need is to have Docker installed and then Minikube, and off you go. Next, let's go ahead and install Docker and then Minikube on our local machine. Let's learn exactly what we need to install in order to get Minikube up and running. And right here, I'm within the Minikube official documentation, which you can find the link under the description of this video. So here you can see that Minikube quickly sets up a local Kubernetes cluster on Mac OS, Linux, and Windows. So also you can find this link under the description of this video. So this is the official Minikube documentation. So here, what I'm going to do is click on Get Started. And you can see that they say all you need is Docker. And for us, we already have Docker installed. And you can see that they said all we need is Docker. And then these are the specs for the machine that we need, right? So 2 CPUs or more, and then 2 GB of free memory, 20 GB of free disk space, internet connection, container, or virtual machine. So we actually have done this part right here, and hopefully your laptop should have, or your computer should have, all of these specs. Now, to install Minikube on Mac is very simple. Just say brew install Minikube, provided that you have brew installed, or you can download Minikube directly, right? So depending on the architecture, x86 or ARM. So in my case, I need to follow the ARM example here. And also you can see that we have installation for Linux in here and for Windows as well, right? So installation for Minikube, it's really straightforward. So let me follow the ones for Mac OS, and let me just close this. So I'm going to download directly. So I'm going to copy this snippet, go back, and in here, so let me just clear the screen. So I can say clear, or I can say Control plus and then L, right? And that will clear the screen. So Control L, and you can see that that cleared. So now I'm going to paste that in, enter. Just give it a second, put my password, and there we go. You can see that was super simple. Now it means that if I clear the screen, I can type Minikube and then version, and check this out. So this is the version that I have installed, 1.24.0, and this is the commit hash, and this is the commit hash. So we are good to go. Now, if I go back to the docs in here, they give us this command right here. So in here, before I run Minikube and then start, what I want you to do is open up Docker and go to Preferences, and within Preferences, navigate to Resources, and within Resources, what I want you to do is to increase the memory. So because we're going to be deploying a few resources to our Kubernetes cluster, I want to make sure that we don't have any issues when deploying resources, because if you don't have enough memory, for example, or CPU, then the scheduler won't be able to schedule any resources once the memory is full. So right here, so make sure that you have at least 6 gig and then apply and restart. Now, when you apply and restart, let me just close this. And in here, if I say minikube start -- and then help, and then if I scroll up, what I want to show you is we have a bunch of configuration here. So including nodes, so how many nodes that we want. But the one I'm interested is memory. So where is memory? So if I scroll up, there we go. So -- and then memory. Now this is the amount of RAM to allocate to Kubernetes. Because we are running Minikube on Docker, let's tell Minikube that it can also take about 4 gigs of memory. So if I clear the screen, and then I'm going to type Minikube start -- memory equals to, and then 4G 4 gigabytes. So 4G, oops. Sorry, I can't type today. 4G. There we go. And this is it. So now I'm going to press enter. And just give it a second. So this might take a while. And I'm just going to sit back and relax until this is done. And there we go. You can see that we have cool emojis in here, and it says done. kubectl is now configured to use Minikube cluster and default namespace by default. Now, what I'm going to do is clear the screen and then type Minikube and then status and check this out. So here we have the type, which is control plane, running in here. So the host is running, kubelet is also running, API server also running, and ready to receive requests from kubectl, and kubeconfig is also configured. Start -- memory equals to, and then 4G 4 gigabytes. So 4G, oops. Sorry, I can't type today. 4G. There we go. And this is it. So now I'm going to press enter. And just give it a second. So this might take a while. And I'm just going to sit back and relax until this is done. So far we have a local cluster with 1 node, and this is the master node. And inside we have the control plane with all of these components that you have learned. And this node has an IP address, which you can grab it yourself by running Minikube IP. So let me quickly show you. So in here in my terminal, I'm going to type Minikube and then IP. And this is the IP address for our master node. So if I go back to the slides, now what we want to be able to do is from our machine to interact with our cluster. And the way to do it is by using this command line application called kubectl or kubectl, as many people pronounce. And basically what kubectl or kubectl, which I'm going to refer as in this course, I prefer kubectl. Kubectl will allow us to interact with our cluster. So as I said, kubectl is a command line tool, and we can run commands against our cluster. We can deploy applications, we can inspect, we can edit resources, we can debug our cluster, we can view logs, and a bunch more. And you're going to learn lots of commands throughout this course. But kubectl will be the command line tool that we're going to use for most of this course in order to learn Kubernetes. And also kubectl is what you're going to use in order to connect your cluster, whether it's running in production or any environment. So you need to be really familiar with kubectl. So the only requirement for you in order to use kubectl is that you need to be confident using the terminal or command line. So luckily for you, I do have this course right here, and it's absolutely for free. So Terminal, Bash, and Vim Essentials. So this will teach you how to navigate your way around the terminal, the commands, how to use Vim, so on and so forth. So this is the essentials that you as a software engineer need to know in order to use the terminal. So if you're not familiar with the terminal, I highly recommend you to enroll to this course right here. Now let's go ahead and install kubectl. So in here, I've got this tab open right here, and you can find all of these links under the description of this video. This is the official page for Kubernetes, so kubernetes.io, and they have lots of links, documentation, blogs, training, community, so on and so forth. So here, let me go to documentation. And here you can pretty much just find a bunch of links that will help you to learn Kubernetes. So here, let's go ahead to this section right here. So set up a K8s cluster. And you can see that we can basically set up the cluster for learning environment or production, but we are learning Kubernetes. And right here, this section, so install tools, contains the list of tools that we need. So in here, remember I spoke about kind, but we are using Minikube right here, and we've done this already. And in order for us to connect to our cluster is by using kubectl. So Kubernetes command line tool allows you to run commands against your Kubernetes cluster. So go and select whatever operating system that you are using. So in my case, I'm on a Mac. And if I scroll down, you can see that the installation process is really simple. All we have to do is just take this curl command, and then if I go back to my terminal, in here I'm going to paste that command, enter, and there we go. That was successfully installed. And if I scroll down, so right here they have a bunch of other things that we can basically do. And what we need to do is we need to actually make kubectl binary executable. So let me just take this and then paste that in. There we go. And move kubectl binary to a file location on your file system. So let me just do this, paste it, and then my password. And let me run this command here. So let's change it to root. There we go. And let's basically just test that we have the correct version and that everything was installed properly. So here, I'm just going to paste that command there. And if I press Ctrl L, enter, and there we go. You can see that we have client version, major 1, minor 20, and this is the git version. That's the hash. So the version is here. So git version right here, the hash, and basically we have successfully installed kubectl. Next, let's go ahead and use kubectl to interact with our Kubernetes cluster and deploy a Hello World application. If you had any issues getting this far, go ahead and let me know, but this should be really straightforward. And if you're not familiar with the terminal or command line, definitely enroll to this course. So for now, catch me on the next one. Right, so we have kubectl installed. Now let me go ahead and give you a quick Hello World using kubectl, and you see how to create an object within our cluster. So what we're going to do is we want to execute a kubectl command against our API server and let the scheduler and the API do its thing and create a pod for us. So a pod is a collection of one or more containers, and you're going to learn exactly what pods are in detail later in this course. But for now, let me show you how to get an application up and running with Docker. So one container up and running, and then let's take the image and then deploy that to Kubernetes. So let me go back to my terminal, and in here, what I want to do is, so make sure that Docker is up and running, and I want to say Docker and then run and then --rm and then -p and then 80 : and then 80, and on a new line, so I'm going to press \, and you don't have to do this. I'm just doing this because my font is really big. And here, what I want to do is say amigos code / and then Kubernetes and then : and then hello and then world. And you can follow along as well. So basically, I do have this image right here, and I'm missing a D there. So this image right here, which is publicly accessible, and this will give us an hello world application. But currently, I'm just running it with Docker. So we're not using Kubernetes yet. So let me press enter. And there we go. Now, if you open up any web browser, and right here, I've got Safari, I'm just going to type localhost. And check this out. So we have this application right here. And you can see that Kubernetes is awesome. We have the logo, which is spinning, and then we have the Amigos Code logo, and we also have a link in here. But currently, we are running this through Docker, right? So what we're going to do is use Kubernetes. So to use Kubernetes and basically have a pod being created, as in the diagram I've showed you. So in here, so what we want is the same, but a pod with a container in it. So to do that with kubectl is as follows. If I go back to my terminal, and what I'm going to do is, so here I'm going to press Ctrl+C. So this will stop the container. And right here, if I reload, you can see that cannot connect to server. So let's clear the screen. And here, let's type together kubectl and then run and then hello world. So this is the name. And then I'm going to add a new line. So you don't have to do this again. I'm just doing it because my font is really big. So / and then enter and then say -- and then image equals and then Amigos Code. So the same image name / and then Kubernetes and then : hello - and then world. And then we also want to say, so on a new line, -- and then port equals to 80. And the port here is the port that the container is listening on. So here, if I press enter, you can see that pod and then hello world created. So this command right here created our pod, and the pod name is hello world. And again, a pod is simply a collection of one or more containers, and more on pods later. But now if I type kube and then ctl and then get and then pods, so we want to get all the pods, you can see that we have this pod name hello world ready, 1 out of 1. The status is running, 0 restarts, and the age is 34 seconds, which is really nice. Now, in order for us to access the application within our pod, there are a couple of ways that we can do this, but for now, let's just use port forwarding, which is only meant for testing purposes. But later in this course, you'll see how we use services to access our application. So here, let's just type for now kubectl and then port - and then forward, and then say pod / and then the name of the pod, so hello world. And then from the host, we want to map 8080 to and then 80 inside of that container. Now, if I press enter, you can see that we have forwarding and then localhost 8080 280. Now let's go and open up the web browser once more. And before, remember, so we just typed localhost, and this time let's type localhost and then 8080. If I press enter, check this out. So you see that our application has been successfully deployed using Kubernetes. So this is a quick hello world, and just to tell you that, so in here, let's just cancel out of this. And basically if I reload, you can see that it doesn't work anymore. And there you have it. So if I clear the screen and then type get pods once more, so kubectl get pods, you see that we have our pod in here. And if we want to delete the pod, let's just say kubectl and then delete and then pod and then hello dash and then world. So you can see that the API that comes with kubectl, it's really easy to learn. So kubectl delete pod hello world. Just give it a second. There we go. If I type kubectl get pods, and you can see that no resources found in default namespace. And you're going to learn about namespaces later as well. There you have it. You managed to deploy your first application using Kubernetes. If you have any questions, drop me a message. Otherwise, let's move on. So in Kubernetes, a pod is the smallest deployable unit and not containers. Now, to visualize what a pod is, I've got this really nice diagram. So this is a pod. So within a pod, you will always have one main container, and the main container represents your application, whether it's written in Node.js, JavaScript, or Golang, whatever language that you want. Then you may or may not have init containers, and more on init containers, but they are containers which are executed before the main container. And then we might or might not have some side containers. So you could have one or two, and also here, whatever language that you want. Now, side containers are containers that support your main container. So for example, you might have a container which acts as a proxy to your main container. Also within pods, we can have volumes, and this is how containers share data between them. Now, the way that these containers communicate to each other within a pod is using localhost and then whatever port that they expose. The pod itself has a unique IP address, which means that if another pod wants to talk to this pod, it uses the unique IP address. So a pod is a group of one or more containers. It represents a running process. It shares the same network and volumes. And one thing to bear in mind here is that you should never create pods on its own. We should use controllers instead, such as, for example, a deployment. And we're going to learn exactly deployments, jobs, replica sets throughout this course, but it's good for you to understand the smallest deployable unit of Kubernetes. Now, the reason why I'm saying that you should never create pods on its own is because pods, they are ephemeral and disposable. Ephemeral means that they're not long-lived, therefore they are disposable. And remember, I said that Kubernetes is an orchestrator, and we have a bunch of controllers that monitor the state of our cluster. So if a pod dies, then if you create a pod on its own, then there is no way that Kubernetes knows how to manage and bring another pod for you. More on this later, but remember I said the smallest deployable unit for Docker are containers, and for Kubernetes are pods. Next, let's go ahead and learn how to create pods. So you've learned about pods, and by now you should know that the smallest unit in Kubernetes is a pod. For Docker is a container, for Kubernetes is a pod. Now, let me tell you something that you should know about pods. So when it comes to using pods, you should never deploy the pod using the kind pod. So you saw that we had the YAML manifest, so this one right here, and you see that the kind in here is a pod. Now we should never do this, and I'm going to explain why in a second. So if I go back to the slides, also you should never treat pods like pets, and this is because they are ephemeral. And ephemeral means that something lives for a very short period of time. So you can expect them to die, or as you know, if you build applications, then you might have version 1, version 2, version 3, so on and so forth, as you have software deployments. We also should know that pods on its own don't self-heal. Let me show you. So in here, I've got this pod right here, hello world, and what I'm going to do is I'm going to say kubectl and then delete pod and then hello and then world. There we go. Now if I type kubectl get pods, you can see that no resources found in default namespace. So I've just killed a pod, and the pod doesn't self-heal, right? So we don't have another pod. Now this is very dangerous because if you have an application, you always want at least one replica of your application running. If there is something wrong with your application, maybe you have a memory leak or you have a bug that causes the application to die, then you want to have a mechanism for the application to basically self-heal, right? So you always have at least one replica of your application. And this is why deploying pods on its own, so deploying pods like this, basically doesn't give us that flexibility. And in this section, you're going to learn about deployments and replica sets, which solves all of this and more. So we should never use pods on its own. Instead, we should manage pods through deployments. Now, deployments is a Kubernetes resource which manages releases of new applications. It provides zero downtime deployments, and behind the scenes, it creates a replica set. So you'll see all of this in action. Now, the way it works is you have a deployment. The deployment creates a replica set, and I'm going to explain replica sets in a second. But basically the replica set ensures the desired number of pods are always running. So in this case, let's say that we want to have 3 pods. So the replica set will make sure that we always have 3 pods, just like this. Now, the deployment really, the purpose of deployment is to facilitate software deployments. So here, let's say that in this scenario, we have the version 1 of our application. Now, if you want to release a new version of your application, Kubernetes will take care of the deployment for you. So it will give you another replica set with the new version, so version 2, and then you have the version 2 of your application running alongside version 1, and then you'll have a software release for free. So Kubernetes will manage all of that. And then once everything is looking good on version 2, then basically you'll have no traffic going to the version 1 of your application. Cool. So we've learned about pods, we've learned about deployments, replica sets. Now let's go ahead and learn about Kubernetes services. So throughout this course, I've been showing you how to access the application using port forward, right? So when we build applications, we want to be able to access our applications, right? So whether it's through a client or service to service, so microservice talking to another microservice. So we want to be able to access the application. So how do we do it? Now, I've been telling you that using port forwarding is only for testing purposes. You should never use port forward. Instead, you should be using services. So you've seen that we have deployments. Within a deployment, we have a replica set, and then the replica set manages each individual pod. So here, let's say that we just have 3 pods, and you also learned that each pod has its own IP address. Now let's take a client and the client now needs to access the application. So how does the client does it? The client could have a list of each IP address associated with each pod. But as I said, pods, they are short-lived because you have software deployments, as you've seen with the rollouts. If a new pod comes in, then a new version of the application is up and running with a new IP address, which means that the client cannot rely on the IP address on its own, right? It's not reliable. So instead, we use services. Now, again, the reason why we cannot use the IP address for the pod itself is that it's because it's unreliable. If we scale up or down, we have new IP addresses. So never rely on pod IP addresses. So instead, in our case, where the client wants to communicate with our application, we use services or a Kubernetes service. So this is an object in Kubernetes, and you'll see how everything works. So now that we have the service, this is much more reliable because the service in itself comes with an IP address. So this IP address never changes. It's a stable IP address. It also comes with a stable DNS name and a stable port. Now, when it comes to services, we have a couple of types. We have cluster IP, node port, external name, and load balancer. So you'll see all of these 4 types in action. So this is how the clients should be talking to our application and not using port forwarding. In this section, let's learn about service discovery with Kubernetes. So service discovery is a mechanism for applications and microservices to locate each other on a network. So you actually use service discovery, but I didn't tell you, I just showed you the magic that happened with Kubernetes. But now let me actually tell you what is happening. So service discovery happens through services. And remember, I've showed you this diagram where we have a client, and if the client wants to communicate with our application, we shouldn't really be using the individual pod IP because pods are ephemeral. They come and go. We shouldn't rely on them. Instead, we should rely on services. And this is because a service has a stable IP address and also it has a DNS. So what is DNS? Let me quickly show you the definition of DNS before we proceed. In here, in this Cloudflare blog, they explain what DNS is, and I'm going to leave a link on the description of this video so you can follow along. But basically, DNS stands for Domain Name System, for short DNS, and it's the phone book of the internet. So we humans, right, we access information through domain names like nytimes.com or espn.com or amigoscode.com, so on and so forth, right? And the web browsers interact through internet protocol or IP addresses. Now, DNS in here translates domain names to IP addresses so web browsers can load internet resources. And what I want to show you is how service registration works. So this is not the actual full-blown example, but this is visually so that you understand exactly what is happening. So in here, when we create a service, we basically register each service to our service registry. And most clusters actually, you'll see core DNS. So this is what is doing all the magic. But basically, you can see that anytime that we create a service, this registers the service name as well as its IP on the service registry, right? So remember, we talked about controllers and watch loops. So basically, anytime that there is a change on our services, we get an entry in our service registry. Then on the other side, this is where, for example, the consumer, right? So a pod or an application can consume whatever data or API that the service exposes by just using the name. So we should never really be using IP addresses. So let me actually show you what core DNS is. So in here, I'm inside of this webpage, coredns.io, and DNS and service discovery. So basically you can read information about it, but basically core DNS is a DNS server which is written in Go, and it's very popular, fast and flexible, simplicity, and also it's part of the Cloud Native Computing Foundation. And you can see some of the users. In first place, Kubernetes right here. So this is really cool. Now, so core DNS is actually another topic on its own, but I'm gonna leave this link so you can follow along and read more about it. Right, the last piece of the puzzle that I want to talk to you when it comes to service discovery is kubeproxy. So early in this course, when we learn about the Kubernetes architecture, you saw that each node has these three components: the kubelet, container runtime, and kubeproxy. So let's focus on kubeproxy because this fits in with this section. So the kubeproxy is a network proxy that runs on each node, implementing part of the service. So we've been learning about services, you've learned about cluster IP, load balancer, node port, so on and so forth. So basically, kubeproxy is part of the Kubernetes service. It maintains rules to allow communication to pods from inside and outside of the cluster. Also, early in this course, you've learned about watch loops and controllers. So the kubeproxy also implements a controller that watches for the API server for new services and endpoints. So you've learned about services and endpoints and how they tie together. Now, when there is a new service and endpoint, the kubeproxy creates a local IPVS rule or rules that tells the node to intercept the traffic destined to the cluster IP, to the service cluster IP. Now, this is important, right? So the name kubeproxy. So here it creates a local IPVS rule or rules that tell the node to intercept the traffic destined to the service cluster IP. Now, you might be wondering, what is IPVS? So IPVS stands for IP Virtual Server, and this is built on top of the net filter and implements a transport layer load balancing as part of the Linux kernel. And basically what it gives us is the ability of load balancing to real servers, as you've seen when we use services where we have a bunch of pods which are behind the service, whether it's a node port or load balancer or cluster IP. And when the traffic is received, then the service load balances between healthy pods. And this is possible because of IPVS. Now I'm going to leave a link on this where you can go and learn more about this, because this is more on the network side of things. But under the description of this video, you can find a link to a page that teaches you more about IPVS. Then what it does, it redirects traffic to pods that match the service label selector. And to be honest, this is the main role of kubeproxy. If you have been following along with IntelliJ Ultimate Edition, what I want you to do is to install the Kubernetes plugin for IntelliJ. So go to Preferences, and then within Preferences, go to Plugins, and then search for Kubernetes. So install this plugin right here, which has 2.4 million downloads and 4.24 rating stars. So this is kind of cool because it gives us cluster interaction, browsing cluster objects and extracting their configuration, viewing and downloading pods, attaching pod to the console, running shell in pod, applying resources from editor, deleting, and a bunch of other cool stuff. So make sure to install this plugin so that you can follow along as I teach you how to deploy our microservices to Kubernetes. And if you don't have the Ultimate Edition, that's fine as well. You'll be able to follow along. But with Ultimate Edition, have a look. We have services in here, and then we have Kubernetes, which currently says a no context. Right click, and then refresh configuration. And now have a look. We have Minikube. If I expand it, you can see that. So in here, let me just make this bigger. So we've got workloads, pods, deployments, stateful sets, job, so on and so forth. So currently I do have one pod, which is hello world, and it gives me information about it, so on and so forth. I can also right click and I can run a shell inside of the pod. So there we go. Now I'm inside of the pod itself. So this is kind of cool. And you can have a look at the network, services, ingresses, configuration, namespaces. Currently we only have the default one, and these ones, they are given to you by default. Nodes, we currently have one node, which is Minikube, secrets, so on and so forth. So you can see that this plugin is kind of cool. Now I'm not going to teach you Kubernetes through here because I feel like that's not the best way. So I'm going to teach you through the terminal or command line, so you see all the raw commands. Finally, let me just close this shell right here and collapse this, and there we go. Catch me on the next one. Let's begin our journey by deploying a bunch of resources into Kubernetes by first deploying Postgres. So we have Postgres, Zipkin, and RabbitMQ, and these are dependencies for customer, fraud, and notification microservices. So with Postgres, what we're going to have is a service. This service is how other pods communicate with Postgres. So the reason for having a service is that the service takes care of load balancing if you have a bunch of other pods behind of your service. And if you want to learn more about this, check my course on Kubernetes where I teach how services work in detail. Then what we want to have is a volume in our node. Then we're going to have a volume claim. So this is how you can basically attach a volume from the host to the pod itself. Now for Postgres as well as Zipkin and RabbitMQ, we're going to use a stateful set instead of deployments. And a stateful set represents a set of pods with a single stable IP as well as storage. So this is the perfect use case for Postgres because we want to persist data, right? So all the roles, all the databases, all of that, we want to persist that data. Whereas with a deployment is a bit different and pods are ephemeral. If you want to learn more about deployments and stateful sets, again, my course on Kubernetes teaches you all of this. Now, just to let you know that you should never deploy Postgres on Kubernetes. I mean in production. But because we are testing things locally, then obviously we can. But if you are planning on deploying your applications to deploy your applications to Kubernetes in production, then you should use a managed solution such as Amazon Relational Databases, i.e. RDS. And this is pretty much a managed database for you. And yeah, you should never run your databases inside of a Kubernetes cluster. RDS is one popular choice, but you've got others provided by GCP as well as Azure and other cloud providers. Let's go ahead and learn how to set up all of this. Within the root folder, let's create a new folder and we're going to name it as K8s. So K8s for Kubernetes. And within Kubernetes, let's yet create a new folder called Minikube. Then within Minikube, let's create yet another folder. And here I'm going to say boot and then strap. So this is where we're going to put Postgres, Zipkin, as well as RabbitMQ. So let's have one folder for Postgres. And within Postgres, let's create a new file. And we're going to call this as config and then map dot and then YAML. So this is where we're going to add in the Postgres user as well as the password. And here I'm going to say K, and you can see that I get some auto completion because of the dependency that I did install. And what I want is the Kubernetes config map. And the name for this will be Postgres-config. And by the way, you can find all of the YAML configurations under the description of this video so that you don't have to type this. So here for data, we're going to have Postgres underscore DB. So we want to have a database called Amigos Code. Let's duplicate this a couple of times. So we're going to have the user and finally the password. So the password, let's just keep it as always. I'm going to say password. So this should be familiar with Docker Compose. Remember at the very top, when we defined Postgres, have a look, Postgres user and the password. So now let me close this. And I've just realized that I'm missing the letter D in here. So now that we have the configuration, next let's define. So let's create a new file. And this file here will be called volume dot and then YAML. And within this file, we're going to define how Postgres will store its data into our Minikube node. And for the volume, let's start with a persistent volume. So here, let me just say K. And I don't think they have a persistent volume in here. So let's just say a generic Kubernetes resource. The API version will be 1. The kind will be persistent and then volume. And then for metadata, we need to have name. This will be Postgres-PV- and then volume. Let's add in some labels. So labels, we're going to say that the type for this will be a local volume. And then the app is Postgres. And we're going to create this app in a second. Now for the persistent volume, we need to specify the spec. We have to have the storage class name. I'm going to say this is manual. The capacity for this will have a storage of 5 gigs. We also need to specify the access mode. And for now, we want read and then write many. And the host path, so host path, this will be under /mount/data. And I'm going to show you this in a second. So this will be the mount path within Minikube. So this is the host. So now that we have the persistent volume, we need the actual claim. And the claim will be pretty much almost the same as this. So let's just take this and have a look, 3 dashes to denote a new resource. And this will be persistent volume and then claim. This time we don't need the type local. And for the spec right here, let's just take this spec and paste it in. And the difference here really is that we don't specify the capacity nor the host path, but what we want to specify is resources and then how much do we want to claim from this persistent volume. So I want to claim the storage as basically everything, so 5 gigs. And just to show you what this volume YAML is, so within our host, we have a claim, and basically it claims everything that this volume has, which is 5 gigs. And then Postgres will be able to store some data. Now let's define the service. So this is how other pods communicate with Postgres. So within Postgres, let's create a new file. And this will be service dot and then YAML. And type K, and we should have a service here. So Kubernetes service. The name for this will be Postgres. The app will also be Postgres, and we'll define this in a second. Then the port, this will be 5432. And what we're going to say is that this will have the target of 5432. So this is what gets sent to the pod itself. And then for the type, let's remove this. I want to basically this service to be only accessible within the cluster. So cluster IP, and there we go. Now let's define the stateful set. So here, just say file and then stateful set dot and then YAML. And this is basically what instantiates the instance. So here, let me just see if they have the stateful set, which is a shame. They don't have all the resources, but we can just create a deployment and then change the name. So deployment, because stateful set and deployment is almost the same thing. So the name of this will be Postgres. And you can see that I'm getting auto completion. So the metadata for this deployment will be Postgres. And then all pods will have the label app and then Postgres. And for the containers in here, let's also just say Postgres. And the image pool policy, I'm going to say if not present. And restart will be always. And this is it. Now I said that this has to be a stateful set. And by default, if you have a stateful set, you need to specify the service name. And the service name is post and then gress. So this service name is this one that we've just defined right here. And we gave it a name Postgres. So then the service will be attached to this stateful set. Now let's define the config map that we have in here, so and attach it to this stateful set. So inside of containers, just say env from, and this will be config map ref. The name will be, so this name here. So if I go back, oops, not there, but this is the name. Command C, go back to the stateful set, paste that in, and there we go. Now we need to specify the volume. So just before containers, let's go ahead and say volumes. This will be Postgres. Then the persistent volume claim and the claim name. So if I go back to volume, have a look. This was the name. So Postgres PC volume. And in fact, let's just say claim in here, because otherwise it will have the exact same name. So this has to be claim. So let's just take this, go back, and then paste the name there. And it's as simple as this. So you can see how things are being connected. Now that we have the volume in here, we have to tell this container that it can basically mount it. And the way we do it is, so within the container itself, we can say volume mounts, and the mount path will be /var/lib/postgresql, and then data, and the name Postgres. And finally, I want to set some resource limits in here. So just say resources, and we're going to have requests. So this will have a CPU, no auto completion there, but that's fine. So 100 millicores, and then memory 256. And for the limits, I just want to cap things. So the same, let's just take CPU and memory, and this will be 5, and this will be 5, and then 12. And to be honest, this is it. So we define the service, the stateful set, persistent volume claim, as well as the volume, and also the config map, which is attached to this Postgres pod, which you'll see in a second. Next, let's go ahead and apply these resources. Within the root folder in here, Amigo services, I should be able to cd into Kates, and then Minikube, and then Bootstrap. So if I type ls, we've got Postgres. So in fact, let me just go back a folder in here, and I'm just going to be inside of Minikube. Now, if I type kubectl get and then pods or po, it's the same thing, we should have our hello world pod, which is running, right? Now, I'm going to basically apply. So if I want to apply all those YAMLs, you can say kubectl apply -f and then the folder. So this is Bootstrap and then Postgres. Press enter and check this out. So config map created, service, stateful set, persistent volume, as well as the claim, everything was created. Now I'm going to clear the screen and then type kubectl get pods -w. So have a look, Postgres 0, and basically it's creating in here. The container is creating, and what it's currently doing is actually pulling the image from Docker Hub. So let me just take this name here and then have a new window. I'm going to type kubectl describe pod and then Postgres 0. And in the meantime, you can see that it's now running. Have a look. So it was creating and then it's running now. But I wanted to show basically, so I wasn't quick enough. So let me just Control C on that and then close this window and Control C here. And basically if I paste this, so let's describe pod and have a look. So these are the events and kubelet. So here, pulling image Postgres in here, pulling image Postgres, and then successfully pulled image and created container, and now it's basically started. So you can have more information about the pod itself, but basically now we have, so if I say get pods, we have this pod, which is Postgres, and it's running. Now let's investigate the logs. So here, just take the name and then say kubectl logs and then Postgres 0. And you can see that these are the logs. So the database system is ready to accept connections. And you can see that. So create database and we are looking good. Now what I want to do is I want to say minikube and then SSH. And remember, within our volume, if I scroll up, have a look, the path, the host path was mount and then data. So this is within minikube. So within minikube, if I say cd / and then here I can say cd and I've got mnt for mount, ls, and have a look, we've got data. So this is really cool. So this is what we've specified in our volume. Now let me come out of minikube. So I'm going to press Control D. And what I want to do is to create a database for all of our microservices. So the way we do it is, so I already have in my search. So if I say sh, and there we go. So this is the command that we want. So here, kubectl exec it, this will be postgres-0. So this is the name of our pod. And then in here, -- sh. Now, instead of executing sh, I want to execute psql -U and then amigos code. So that was the user. Enter. And check this out. We are inside. So we are inside. Now, if I type \l, you can see that we have the amigos code database that we specified in our environment variable. And what I want to do is to create a database. So create database customer. Let's also create a database for fraud. And finally, notification. And job done. Now press Control D. And if I show you get pods again, so you see the pod, there we go. So we've managed to SSH into this running pod. We created the databases, which later our microservices will need. And congratulations, you've managed to run Postgres on Kubernetes. But as I said, in production, never do this. Do this only for testing. And also you can see I'm teaching you about all of these different components that Kubernetes has to offer. Next, let me set you an exercise. All right, we have Postgres up and running within our Kubernetes cluster. Next, what I want you to do is to deploy Zipkin and RabbitMQ. So these resources, Zipkin, RabbitMQ, and Postgres, they are dependencies for all of our microservices. Now, both Zipkin and RabbitMQ will be a stateful set, and luckily for you, I already have the YAML configuration that you need. So all you have to do really for this exercise is copy and paste the YAMLs into your local file system, following the same file structure that we currently have for Postgres, and then apply those YAMLs using kubectl. Give that a go, and I'm going to give you the solution next. All right, let me give you the solution for the exercise. Now, I'm not going to spend time explaining all of these resources because RabbitMQ and Zipkin, this is not technically the correct way of you deploying them to Kubernetes if you are running things in production. So this was me trying to figure out ways of deploying RabbitMQ and Zipkin, and I've managed to do it using stateful sets, which is pretty much almost the same as Postgres. For Zipkin and RabbitMQ, we are not storing anything, but we could. I think Zipkin depends on MySQL if you want to persist data. I'm going to leave some links where you can learn more about these resources. And also, if you are interested, check my Kubernetes course where I go in much detail and cover all of these resources. But all I want you to do is just trust me. I gave you these resources, and make sure that you put them inside of Bootstrap, and then have a folder for RabbitMQ, all of the YAMLs, and then for Zipkin as well, have these 2 YAMLs. And once you have this set up, you can apply these resources. So let's open up the terminal, and in here I'm going to apply, and then instead of Postgres, in here let's apply Zipkin first. There we go, we have Zipkin. And finally, let's apply RabbitMQ. Now I'm going to get the pods and then -w. And you can see that currently these have the status container creating. So basically it's just pulling the Docker images. So just bear a second, and you can see that Zipkin is already up and running. And there we go. You can see that RabbitMQ seems to be running, but 0 out of 1 is ready. So you can see for Zipkin 1 out of 1. So let's just wait a little bit. And in fact, let me just check the logs to make sure that everything is fine. Control C and just say logs. So kubectl logs, and then here say RabbitMQ and then 0. So 0 is the name of this pod in here. Press enter. And if I scroll up, things seem to be fine. So let's just get the pods again, and there we go. So now it's ready. Actually just took a while, but you can see that it is ready. So 1 out of 1 for Postgres, RabbitMQ, as well as Zipkin. Let's check the logs for Zipkin. So kubectl logs Zipkin -0, and you can see that this is very familiar. So it's basically serving on 94.11. And also what I want to show you is if I say kubectl get and then all, and in here you can see all of the resources, pods, services, and then stateful sets. But what I want to show you is we have RabbitMQ and the type is node port, and then Zipkin, the type is load balancer. Now you can check my course to understand the difference between all of these types. But let's go together first and learn how we're going to access both RabbitMQ as well as Zipkin. So with Minikube, we have this command, minikube, and then service -- and then URL. And if I scroll up, I just want to show you that. So the service name that we need is RabbitMQ. So here, and then space RabbitMQ. If I press enter, starting a tunnel, and now check this out. We have this URL. Now I can take this URL, and the reason why we have 2 is because of the AMQP protocol for our microservices. But here, let's open up our browser and then open up a new tab, paste that URL, enter, and check this out. We've accessed RabbitMQ. So the username is guest and the password is also guest. Don't save, log in, and I think I've mistyped guest. Yes, I did. So there we go, guest, and I'm inside. So you can see that RabbitMQ. So you can see that RabbitMQ is running on Kubernetes. Now let me go back to the terminal and let's do the same for Zipkin. Now, because I'm using Docker, I need to keep this terminal open. So I'm going to open up a new shell. And here, let's just do the same. So let's just say minikube service -- URL and then Zipkin. And starting, and you can see that we only have one URL this time. because we're only exposing one port. So let me just take this URL, go back to my web browser, new tab, paste, enter, and check this out. So we should see Zipkin in a second, and there we go. We have Zipkin also up and running with Kubernetes. So which is really nice. Now, one thing that I want to show you is, so here, if I press Ctrl+C on the Zipkin one and then clear the screen and then type kubectl get and then pods, or actually get services, have a look. This is pending right here. So for Zipkin is pending, the external URL right here. And this is because the type is load balancer. Now, if you want to access the load balancers that you have within your Minikube, you can just say Minikube and then tunnel. And what this gives me now is the ability to access my service on the specified port, which is 9411. Currently, this port, so it's 68636. So this is a random port that was chosen. But because the type is load balancer, so here now, if I open up a new shell and then type get services again, have a look. The external IP now is localhost, and that means I can access through the correct port. So now this will be 9411, enter, and you can see that this also works. Now, I'm showing you different ways of you accessing your services within Kubernetes so that you are aware of. But in my Kubernetes course, I cover all of this, and we did it. Let me now close this window. Let me also stop the tunnel, and also here, I want to close everything. And if I clear the screen and then type get, so let's just get pods, and there we go. We've done it. We have Postgres, RabbitMQ, as well as Zipkin up and running within Kubernetes. Now, these are the resources that our microservices depend on. Next, let's prepare our microservices so that they can also run within Kubernetes. So we actually built quite a lot, and I have to be honest, I did teach you a couple of things just so that you are familiar with the entire concept. So I've showed you how to have an API gateway up and running, but to be honest, when you move to the real world, you kind of want to pick a managed solution for you, right? So you can imagine with this API gateway, we need to manage it ourselves, configure certificates, make sure that it's a Z, i.e. it runs in multi-regions, is high available, and with that, you actually need an ops team just to manage the load balancer or the API gateway, because that is the main entry point of your application. If that goes down, then it's a severity 1. So in this section, what we're going to do is we're going to refactor a couple of things and just keep what we need, And also you'll see that for service discovery as well, so Eureka client and the server, those are things that I did show you so that you understand how to use them. But again, because we're going to deploy to Kubernetes, and these days pretty much everyone deploys to Kubernetes, then Kubernetes offers us service discovery for free, which is one less thing to worry about. Let's do some refactoring so that we can prepare our application to a Kubernetes cluster. At this point, we no longer need Eureka Server for service discovery because Kubernetes offers that for us for free. Again, Kubernetes offers service discovery for free. Now, this is good news because we have one less service to manage, which is the Eureka Server, and less configuration. So when you deploy things to Kubernetes or to production, the better it is because less things to look after and maintain. Now let's disable Eureka Server for our microservices. So within customer, src main resources, application.yaml, just say enable and this is false. Let's also do the same for application-docker, and for fraud, the same thing. There we go. Application-docker. There we go. And finally, notification. So obviously, you can remove the annotations that we've used and also delete this, but I'm just going to leave things in there so that you have for reference. So resources, and let's disable here, and application-docker. So in here, disable it like so. So there we go. So we no longer need Eureka Server because Kubernetes gives us service discovery for free. Let me close all of these, and there we go. Now let's go ahead and refactor the clients module. So in here, open up main, Java, and then fraud, and then the client. Have a look. So this right here will no longer work because we're not using Eureka client. So we have to specify the actual URL. Now, because we want to be able to run the application either locally or Kubernetes, what we're going to do is to play with profiles. Now, inside of resources, what I want you to do is right click, new, and then file, and this will be called application clients -default dot and then properties. Now, for what we are about to do, I tried to use a YAML file, but it didn't work. For some reason, it worked with properties, but not with YAML. But I will show you exactly what I mean in a second. So here, what we're going to do is define the configuration for how clients find their targets. So let's start with, so I'm going to say clients dot and then customer dot URL equals to, and this will be HTTP colon / localhost colon and then 8080. So this is customer URL. Let's also define, so we're going to define all microservices, even though customer, I don't think we have a client for it. So let's define fraud. So fraud was on 8081. And then finally, this has to be notification. And there we go. Now let's duplicate this. I'm going to press Ctrl+C and then Ctrl+V. And here we're going to have clients dash and then cube. And then OK. And for how we connect to customer inside of Kubernetes, we're going to change this to HTTP and then customer. This to fraud and this to notification. Now you might be wondering why I'm not specifying, for example, column and then 80 and then 82, for example, right? And the same for fraud or customer. With Kubernetes, what we're going to do is for the service will listen on port 80, let's say for notification, and then it will forward to 8082. Therefore, this is the port that pods will need to talk to and not 8082, which means that we can get rid of all of this right here. And the cool thing about Kubernetes is that this right here, so it's not localhost or an IP address, but this is the service name. So notification, fraud, as well as customer. So in here, what I'm saying is, so this is the service and the port will be 80 and then the target will be 8080, which is for customer. In this one right here, the port for this service will be 80 and then the target for fraud will be 8081. And for notification, I think we don't need a service because notification talks to the RabbitMQ to pull messages. And to be honest, this is it. Now let's open up the clients, so both for fraud and notification. So here, let's just in here, we're going to basically, so if I press Control space, we can specify the name. This will be fraud, but more importantly, we can specify the URL, and the URL will come from the configuration file. So $ curly bracket and then clients dot and then fraud dot URL. Let's take this and do the same for notification, and there we go, and this should be notification. Now in order for this to work, we need to open up, so let's open up customer, src main, and then customer application, and in here I'm going to say at and then property sources, and inside I'm going to say that I want to basically have the property source from the class path. So this will be class and then path. If I press Control space, you can see that we have client's default and client's cube. Now the way that we're going to tackle this is by adding $ curly brackets and then say spring.profiles.active. So this will either be default or whatever profile that we are using. So if we're using default, it will use this properties file, or if it's using the cube profile, it's going to pick up this property file. Now in here, so I think this is where things didn't work for me when I tried this properties. So I tried YAML, so using YAML syntax, and it did not work for some reason. Now I'm not sure whether if it's YAML like that and that's why it wasn't working, but I tried YAML like this and it did not work. So let's just stick with properties, and if you manage to change this to a YAML and get things up and running correctly, please do give me a shout. But I just realized that, so here this should be clients dash, so clients dash, and this will be default or cube, so this right here dot properties, which matches these two properties file. Now let's take this in here and let's add it to fraud, so fraud application, paste that in, and let's also add it to notification, notification application, and then paste it in, and job done. Now let's try and start all the applications and see whether we have successfully refactored things so that we can run all the services locally, because it's really important that we get things working locally before we move on, right? So let's go to so in here, let's open up the Docker Compose. And what I want to do is for Eureka server, if you want, you can basically comment it out. And for the API gateway, let's also comment it out. There we go. Now you can see that we have customer, we have basically all of these. So what I want to do first is I don't want to start these. So let me just comment these just for a second. So comment all of these, comment, and basically I just want to start. So if I scroll up, I just want to start RabbitMQ, Zipkin, pgadmin, and Postgres. So back to my terminal, and within the root, let's just say docker compose up-d. And there we go. So you can see that it's starting these 4 containers that I need for local development. So we could actually have 2 Docker files. So one for, well, it seems that I need more memory. So let me just ignore for now and see if I can complete this video. So what I was saying is we can actually have two Docker files, one for the Bootstrap services and the other one for all applications if you don't want to comment things. But for now, let's just keep things simple. And if I type docker compose ps, you can see that we have pgadmin, Postgres, RabbitMQ, as well as Zipkin all running. Now let's try and start our applications with IntelliJ. So within IntelliJ, let's try to start customer and see whether it works. So I know that this will fail and I'm going to explain why, but you can see that this fails immediately. And it fails because of, so in here, it's complaining about, so in here, could not resolve placeholder spring profiles.active class path, and then here. Now, because we haven't activated any profile and still, so here it says no profile set, failing back to profiles default. So I think this must be a bug within the framework itself. But if we don't be explicit about the profile, this does not work. So this in here does not work. So what we have to do instead is, so go to, click on customer, edit configurations, and then in here, environment variables. So the same way that we've done, if I open up Docker Compose, remember for Eureka Server, we had Spring Profiles Active Docker. So here within customer, we have to do the same thing. So here, environment variable, and this will be default. Now, even though, so as I've showed you, so even though the default, so failing back to default profile, which is default, it doesn't recognize it for some reason. I don't know why, but this must be a bug. And if you find out why, please let me know. So now if I try to start customer, this should work. So this $ and then basically replacement should work. And there we go. You can see that starting on 8080 and within 7 seconds or so. Now let's do the same for fraud. Paste that in, and this should be default. Let me just take that, apply. And the only reason why we're doing this is because of this file, right? So this file that we have within our clients module. So clients-default or clients-cube. So let's start fraud and also notification. So edit configuration and then add in environment variable, default, apply, OK, and then start. And there we go. We also connected to RabbitMQ. And let's test this by opening up Postman. And before we used to send requests to the API gateway. Now we're going to send it to customer, because in local development, it's fine for us to talk to these microservices. But when we move to environments, such as dev, testing, prod, so on and so forth, then we have to go through a gateway. But for local development, it's fine. So if I send the request, and there we go, you can see that it's a 200. So we've managed to refactor things so that we can develop these microservices locally. This is all for now. Catch me on the next one. We've managed to start our application with clients-default properties in here, but we also have the clients-cube properties. Now we also have to have this profile or the similar file within customer, fraud, and notification. Because if we select this profile, it will pick up this file, but for the rest of the microservices, it won't. So let's go ahead quickly and open up customer, src main, resources, and in here, just duplicate the application-docker. So this will be pretty much identical to Docker one. So name it cube. And let me just expand this and show you. So basically everything will be the exact same thing. So this will be Postgres. So this will be the name of the service, which is this service for Postgres. So this is how other pods communicate with Postgres. Then if I scroll down, so the password will be the same. So we're going to make sure that this password, oh, actually, I think we did set up the password to be Amigos code and then password within the configuration file. So if I open up the YAML for Postgres, and in here, this is the config map, Postgres config, Amigos code, oh, actually, this is the user, Amigos code, and then password. So this has to be the exact same thing as these. This is the name of the service, and then the default port is 5432, and we also have created this database in here. Now, create drop. So I'm only using this for testing purposes, but usually you don't want to drop your database all the time. But in my case, I really don't care. And in here, if I put my mouse in there, you can see that create and then destroy the schema at the end of this session. So usually you'd have something like maybe update, or if you are just creating, for example, your schemas with Flyway, then you want, for example, none or validate right here, right? So you just want to validate the schema, but make no changes. So Zipkin will be the same. So this Zipkin and RabbitMQ. So we have Zipkin in here. So this will be the name of the service. So this service, when I mean service, I mean the Kubernetes service, right? So this guy right here. So the name of this Kubernetes service is called Zipkin. And for RabbitMQ, this one right here is also called RabbitMQ. I'm just leaving it as Zipkin and RabbitMQ. Then the ports, we're going to leave everything the same. And we could actually change this to basically just invoke Zipkin like that. And this would have been 80, right? But we can remove this if the services are listening in on port 80, but I don't think we did that. So let's just leave the default, and within, so clients, SRC, and then resources, have a look at the client's cube.properties. So this is customer in here. And this is because customer service is listening on port 80 and then sending the traffic to 8080, right? So this is one solution, but we're not doing this. So let me just go back, and this is it. And obviously with Eureka server, you can actually remove all of this since we're not using it, but I'm going to leave things in here so you can have it for reference. Now let's do the same for fraud. So fraud, and then in here, just duplicate that and then say cube. And at this point you might be saying, so why can't we just use Docker in here? So it's best for us to keep these separate from each other, because this right here will change. Eventually it will change, especially when you start to use configuration which is only specific for Kubernetes. Then you don't want to basically mess around with this file and then affect the local Docker testing that we have with Docker Compose. So let me collapse this. Notification the same, main, resources, duplicate that one, call it cube, and there we go. So this is pretty much it. The final thing that we have to do is to make sure that we can run our microservices with Docker. So let's actually make sure that we can basically test things with Docker as well, because usually it's good for us to test things locally. And also, if you have a new joiner in your team, then they can just run a set of containers and have the entire application stack working without no effort. So inside of clients resources, we need to create the clients-docker profile. So let's just say clients-docker. And this will actually be the exact same information in here, but we have to specify the ports. So this will be 8080, this will be 8081, and this will be 8082. Now, if we were using port 80, then we wouldn't need to specify the ports. But with Kubernetes, we are using this service, which is listening on port 80. So that's why. So again, in here, let's just make sure that we have a separate profile, just to make sure that things are consistent across our project. Now let's open up the docker compose.yaml. And before, remember, we did comment out a few things. So Eureka Server, we don't need it anymore. API Gateway, we also don't need it anymore. And then just uncomment customer, fraud, as well as notification. Just like that. And also, let's just remove the dependency in here. So we no longer depend on the Eureka Server, but we still have to depend on these three services. The same here, and the same with customer. And to be honest, this is it. Now let's test this out. Open up the terminal. Let's build a new image with Maven Clean package. And there we go. So we have new images. Now we can pull those images. So here, clear this, docker compose pull. And you can see that it's just pulling so notification. Some layers already exist, so this should be really quick. There we go, finish. So here, say docker compose up -d. So you can see that Postgres, RabbitMQ, Zipkin, pgadmin already running, and we just have to start these three. So just give it a second, and there we go. Now let's open up Postman, and within Postman, I'm going to send a post request, and before we sent to our API gateway, but now we can send it to customer directly, which is on 8080. And it's absolutely fine for us to send a request to customer during our local development, because I think I've mentioned this before, but as we move through environments, so for example, dev environment, test, prod, then we won't be able to test this directly, provided that we go through an API gateway or a load balancer. But for testing purposes, it's fine. So let's just send the request. And bingo, have a look. We have a 200 status code. Now, obviously, you can go and check Zipkin, the database, and all that stuff. But I can guarantee you that we now also managed to have Docker local testing up and running. Now, within my terminal, let me basically say Docker compose and then down. So I want to get rid of everything. And if you want to basically get things up and running again, you can just say Docker compose and then up -d, and off you go. So this is it. If you have any questions, feel free to let me know. Otherwise, let's move on to the next section, because now we are ready to deploy our microservices to Kubernetes. This is all for now. Catch me on the next one. Okie dokie. So we have RabbitMQ, Zipkin, and Postgres, and we also refactored customer, fraud, as well as notification to work within a Kubernetes cluster. So now let's basically deploy all of our microservices. So to deploy customer within Kubernetes, let me go ahead and close this file and this file, and within minikube folder, let's have a new folder, and here I'm going to name this as services, and within services let's have customer. So this will be yet another folder, and basically per microservice we want to have a different folder with their YAMLs. Now, in order for us to deploy customer, we need the following. So here I'm going to have a new file, and let's start with the service. So I'm going to say service dot and then YAML. Here I'm going to use auto completion, so K and this is a service. There we go. And here the name will be customer, and then the port will be 80. And we're going to say the target port is 8080. So again, 80 here is so that we remove the need of specifying ports from our applications. So if I open up clients, have a look, clients-cube.properties. Here I'm just saying customer. So customer refers to the name of this service, and the port is 80. If I had 8080 in here, then this would need to be 8080. But we don't want ports, so let's just get rid of that and leave this as 80. Now for the type, I want this to be a load balancer, and I'll explain load balancers in a second, but effectively in here we are configuring the service, and I'm saying that this will be type load balancer. Now really what we want is to have an ingress in here, but we're not quite there yet. So for now, let's just say load balancer. Now if you're running Kubernetes in, for example, EKS, that will spin up an application load balancer for you. So it will spin up an application load balancer for you. And again, we don't have this ingress yet, but I'll touch on ingresses in a second. All right, and this is pretty much everything we have to do for the service. Now let's create in here a new file, and I'm going to say deployment dot and then YAML, and here I'm going to say K, and I'm going to choose Kubernetes deployment. The name for this will be customer. Now make sure that the replicas is 1. Make sure that replicas for now is 1, and I'm going to explain this in a second why, but for now just leave it as 1. Then for the image, we're going to say this is amigos code / customer column and then latest. And if you don't specify this tag, it will basically pull latest anyways. Now for image pull policy here, you can basically change this to always or never. Actually, you don't want never. So maybe you always want to pull the latest image, or if not present. And in fact, let's just say always. So because we are testing things, it doesn't really make a difference. Next, we need to define the ports. So ports, and the container port for customer is 8080. There we go. And last but not least, I want to specify the environment. And here, so remember, within our Docker Compose, we have Spring Profiles active equals to Docker. So we want the same thing, but the value will be cube. So customer in here has this, oops, not there, but in here it has this application-cube.yaml. So we want to select this file. And to be honest, this is the configuration that we need. Obviously, we can configure resources, limits and requests. We can also configure the liveness and readiness probes, but this is the bare minimum configuration that you need in order to have a deployment with one replica up and running. Now, the reason why I said 1 in here is because if I open up the application-cube.yaml, in here, have a look, the Hibernate DDL auto, this is create drop. This is create drop. So it means that if a second pod comes along, it will basically destroy the database. So this right here, you only have it for testing purposes, and you can go and basically say, for example, update, so that it doesn't delete data. And in my case, I really don't care about the data, so I'm going to leave create drop. And in the replicas, I'm going to leave as 1 as well, because I also don't think I have many resources, because I only have 16 gig and I've got a lot of things already up and running on my machine. So I'm going to leave the replicas to 1. But usually you want to have 3 replicas at least, so that your application is always up and running if one fails, right? But again, this is when you go to production. For testing, you can leave it as 1, and this should be okay. And there we go. This is customer. Next, let's apply this YAML. All right, let's apply the YAML that we've just added for customer. So let's together say kubectl, and I'm inside of the Kates folder. I'm going to say apply-f and then minikube services and then customer. There we go. Let me say kubectl get pods, and we have container creating. So this is actually pulling down the image from Docker Hub. So if I say kubectl describe pod, and you can see that, oops, that was quick, successfully pulled image. And if I clear this and then run get pods again, you can see that customer is running. So 1 out of 1 is running. Let's check the logs. kubectl logs, and then paste the pod name. And I can say -f for tailing the logs, and check this out. So this should be familiar to you. So if I scroll up, you can see that we have our banner in here, customer. And basically this is the startup process, create table customer. And then in here, you can see that started customer on port 8080. And it took about 15 seconds to start up. And there we go. We've done it. We have our customer microservice up and running in Kubernetes. Now, if I press Ctrl+C in here and then open up the YAML configuration, and here, let me just put 2. So you see that we can have 2 replicas as well. And I'm going to apply. There we go. Get pods. And the second one is creating. So let me just say -w. And there we go, both up and running. You can see that they are both running. And if I press Ctrl+C, and I think, so this one was the one that we checked before, which is running cool. This one is the new one, 14 seconds ago. Let's just check the logs for it as well. And there we go. So this one is also running. Now have a look. This second one drops the table and also creates the table in here. So this is why I was saying that it doesn't really make sense for you to have more than one replica up and running with auto DDL create drop. But you can see that we have both pods up and running. Let me press Ctrl+C and let's check the services. So kubectl get svc, and this is the customer service, type load balancer, cluster IP, port 80, and then it maps to this random port. And there we go. So at this point, it doesn't really make sense for us to test the entire flow, because we need fraud as well as notification microservice up and running in order for us to test that we can make a request from customer and then traveling through all the microservices. If you have any questions, please do let me know. Otherwise, let's move on. Okie dokie, let me give you the solution for the exercise. So in here, I'm going to do it from scratch so you see how I would do it. But what I'm going to do is Command-C on customer, paste that, name this fraud, and in here for fraud, I'm going to perform a control, search, and replace. So I'm going to replace customer with fraud, and then replace all under the fraud folder. There we go. You can see that all replaced. Then the port will be 8081. Open up deployment, And here, let's just make one replica, and for customer as well. So one replica. And as I said, in production, you want to have maybe 3 at least. So here, go back to deployment, and the image is fraud. Container port, this is 8081. And there we go. Let's do the same for notification. Command C on fraud, name it notification, and then perform a search and replace. And you can see the keyboard shortcut down below.